Hey, hello everyone. In today's video, I'm just gonna explain how you can use InfluxDB in real time when you have a huge amount of historical data. And I just took an example of a trading platform where we have a historical data for last 10 years, for 214 stocks from an NSC. Actually, I was just trying to help one of my friend who is actually in this trading business, and he really needs my help to just optimize the process of loading a data to the InfluxDB. And he also needs my help on just, optimizing a real-time data storage with Redis as well as for the InfluxDB, where Redis is going to the main memory where all the calculation will be happening to have a lowest latency as possible. But as a backup, we want to just whatever the operations on the calculation we are doing in a Redis, we have to move that to into the InfluxDB. But today, in today's video, I will be just showing if you have a huge amount of historical data, then how you can just move to the InfluxDB in the most performant way. There are multiple layers on which you can do the optimization. So I'm just focusing today on a code level optimizations, for InfluxDB, like what can you do at the application level or the code level or the software level. Then the next one would be the hardware level. The third one would be the network level, right? And infrastructure level. So these are some different stages on which you can just start optimizing your code. So as you can see on my screen, in FlexDB, I have a last 10 years of data, which you can see on my screen. We can just check on something for a different stocks as well, right? So what we're going to do in today's video, I'm just going to explain how I just set up this and what kind of optimization I have done it, right? So the very first layer which I was having is, we have InfluxDB setup. Definitely, I will be using a Docker Compose because that's the way to just set up any complicated infrastructure in a very simple way. So I'm using InfluxDB2 to start with, and I have a bunch of environmental variable which I have set up. I will be just putting all those things in a GitHub. So if you find any issue in just accessing my repo, you can just always send me a message and I'll give you the access, right? So this is how we are going to set the InfluxDB. Then I have a Grafana. You don't need to worry about Grafana for this particular video. Probably in the next video, we will. This is the main part where we are actually doing the loading and the cleaning of the data. So what happens in a real time is this is the data. So you can see we have 214 stocks where we have a good amount of data, right? For close to, it's between, 50 MB to the 90 MB for all the 214 stocks. And if I just show you the size, it would be somewhere around 14.8 GB, right? So what I have done is I have already uploaded, this historical data, and you can see the final history over here. And I'm going to just set up this one more time so that you can just see the things in action. And I will be explaining how I just optimize this code at the code level, little bit of, optimization at the infrastructure level, but that is not completely utilizing the optimized hardware and the infrastructure or the network. But that would give you the fair amount of, sense how you can optimize the code and how you should first start with the application level or the code level. And then you have to move to the hardware level or the network level, depending upon what kind of problem and which layer you are getting that problem. So here, if you just see, we have total files 215, total points this much, which is close to 188 million data points. Then this is the throughput which we can achieve, right, in terms of points. Then this is the throughput 1.26 GB per minute, which is so awesome. But definitely there is a huge amount of scope which we can optimize, right? So I'll just give you this, very high level view how you can optimize that, because that's the most important part, how you can optimize the code, right? So what I'm gonna do now, I'm just gonna clean up the environment, right? So I have already explained we have 214 G of 214 stocks, with the last 10 years of data. We are going to load this. So how we are going to load this into the InfluxDB. So let me just quickly share the code which I'm gonna use here. Though it is RAD, but this is the actual file where we are actually going to do the magic, right? So here you can see we have just imported bunch of libraries. If you have been following my InfluxDB, you know about all these things. There are some important, library which I wanted to highlight: the ThreadPoolExecutor, the asynchronous one. This is in asynchronous. I have already explained, and most of us already know that. But ThreadPoolExecutor is definitely an important concept because when you move a data to the InfluxDB, it's kind of a IO operation, which is going to be very intensive. So rather than going for the multiprocessor, you have to go for the multi-threading. And that's the reason we are seeing a threading pool. And asynchronous mode is very important in such scenario because you have to ensure that wherever you have a wait period, you should be doing that particular process and activity in an asynchronous mode. Right. So these are the three important factors which you have to keep in mind, because we are not going to load all the files in one go. We have to just create a batch. So rather than sending all the files in one go, we are not going to do that. Same thing. So batch size is basically for one given file, how many number of records we are going to just, fed in. Max thread is again, just to achieve like, how many threads we want to open at any given point in time. Chunk size is again, it's again inside the file, how many records you have, which is quite confusing here. Batch size and this chunk size, and we just gonna see how we are going to use this, right? Okay, so now here, earlier, before the optimization, I was using this create line protocol batch, right? Which was taking a lot of time. So here, if you just see, I was using pandas data frame, right? But it was taking a little bit longer. So then what I did is I just go for the NumPy array, right? So here, if you just see, we are just trying to use the NumPy array rather than using, the data frame to load to the data. So here you can see I was just directly writing creating a line protocol, right? And before that I was using a point as well, but that's a different story. I'll just explain you. But here, if you just see, before just, returning this line protocol, I'm just converting that into the NumPy array. Right. So because that is actually going to help us, so here you can see the value is going to be converted into the NP init 64. So that's a really important thing. You have to just keep looking into the situation where you can just use NumPy array, and then what we are doing here is we are just trying to load a one CSV at a time. And for that, we are just creating a line protocol. And here, if you just see, we are doing the same thing. So why we are creating a single line based function? Because this is what we're going to fed to our ThreadPoolExecutor. Right. So here, if you just see, here we are using going to be use a chunk, right? So chunk size means and how many records we are going to pick from the any given CSV. So first level of, the batch, what we're going to do, we are not going to fed, all the CSV in one go. We are going to create a batches, right? So if you just see here, okay, cooldown files per batch. This one is important one. So we have 25 files in one batch rather than feeding all the 214 files. We are going to use 25 files per batch. So what does this mean? If we have a 214, if you divide by, then we're gonna have a 9 batches, and that is what you can see on a screen. Okay. So before I just go into the explanation, let me just quickly start the network. It is going to take some time. Okay, so coming back to the code level. Okay, so what we had done, rather than using a point to write to the InfluxDB, we are creating a line protocol. Then we are using a chunk size where we are saying how many records from a given CSV we are going to pick. We are not going to fetch all the data in one go from one given CSV. So that's the reason at the CSV level, I'm creating this function because I want to feed this to the thread pool as a function. Right. So process file in a batch. Again, here we are using a thread pool executor where we are saying how many records, how many threads we want. So this max threads, these chunk sizes, these batches, you can use to just play with, and you can see, what values you can change and how it is going to impact the records, right? So here you can see, I think we are using a chunk size, and then we are creating a batch as well, right? So we are taking a length, chunk, and a batch size. So what we are saying here is how many chunks we want, and then we are saying the batch size. What does it mean? So if you just know, this is what the entire length of any given CSV basically, and then we are saying whatever the batch size we have, and based on that we are going to create a batches. So basically chunk size is going to be used. So batch size is actually going to give you the another level of control on how many records you want, right? So that is how it is being used. So here process file batch, here you can see what it's saying, thread pool executor. So how many threads we need? We need based on the max threads, which we have defined as a 4. And now here you can see in future we are just submitting that function. So this is the same function where one single CSV file is going to be used, and that is where we are using a chunk size to just create a chunk, and the batch size, like for how many batches we want to create for a given CSV. So let's assume we have 2 million of records and the size is 1 lakh records. Then what's going to happen? It's going to create a 20 20 batches for any given file, right? So first we are going to just do the batching at the how many files we want to push into the one batch, and then we are just going to do the another level of batching, like how many records we want to put in a one line protocol. So these are again depends upon the memory, what kind of memory you have on an InfluxDB side, because we have to make sure that we are not overburdening, our InfluxDB, because if you push all the files or all the records, your InfluxDB server is going to be crashed depending upon how much memory it is having, right? So I can quickly show you with the resource monitor. Here you can see the CPU uses already 80%. You can see the memory is 64%. So now it's very CPU intensive process is actually being run. If you just see, I can quickly show you that what I'm doing here in a scheduler. Right, so if we just come here, like how many cores we have? 18. So batch chunk size is 50,000, right? So what it is doing, the very first thing it is doing, it's just trying to clean the file. So what happens is this is just a functional requirement for the trading. Whenever we get the data, there are a lot of anomalies in the data which needs to be cleaned up. So we are doing a lot of check, and that's the reason this is very CPU intensive, because we are doing a lot of manipulations. Whenever the manipulation comes, it means that it is going to be a CPU intensive process, right? So that's the reason it is utilizing most of the CPU now. But when you just clean the data, your cleaning is done, your CPU intensive process would be down, and now you have to move that clean data to the InfluxDB, and that is where this code will come into the picture. So process, file batch, ThreadPoolExecutor. So what we have done, so we have used for concurrency to achieve a maximum concurrency, we are using a thread pool, right? So what we had done is, rather than using a simple line protocol, we have used a NumPy array. Why we have used a NumPy array top of our pandas data frame? Because so that the memory footprint can be reduced and we can just achieve a higher throughput with the low latency, right? That's one thing. The next thing is, if you just see, we have used where we are just creating a InfluxDB client. I mean, these are some important things which I'm just giving you here, so that whenever you are going to just optimize that, you have to make sure that you are using all these things and you are just keeping all the things in mind. So this is again a code label, not a code label but the network label, but through code you are handling this. Enable gzip. Gzip means you are going to compress. So whatever the line protocol you are creating, because you are having a very large batch size, right? So batch size means how many records you are going to take from one given CSV. So at that point of time, if you just try to move the entire data over the network, because what you're going to do through scheduler, you are going to move that data to the InfluxDB, then definitely your network is going to be exhausted with that. So in that situation, what you can do, wherever you are trying to just move the high amount of data, you have to make sure that you are using the most comprehensive, the most latest advanced comprehension algorithm, so that you can just reduce the bandwidth on which you can just send the huge amount of data by compressing it, right? So this is another level of the optimization. So what we had done, we created batches, we used a line protocol, and then rather than using a pandas data frame, we are using a NumPy. And then when we want to move that data to the network, we are using a compression by enabling this enable gzip, right? And then just to achieve a multi-threading, because it's a IO bound, because this loading is going to be a IO intensive task, right? So now we can just move again and we can see what is happening with our system. Here, if you just see this disk IO, right? This IO is actually completely exhausted here. Why? That's the reason I was able to understand. When cleaning was happening, it was, the CPU intensive. But now when we are just moving a data, the clean data to InfluxDB, now it has become a IO intensive. And that's the reason we are using a multi-threading rather than going for the multi-processing. So I hope this clarifies why we are using a thread pool executor over the multi-processing. Right. So first you have to identify and establish whether your process is CPU intensive or IO intensive. And that is where this resource monitor will help you to understand, right? So you write the code, you run the code, and then you will understand which process or which function is a CPU intensive and which function is your IO intensive. And accordingly, you can decide whether you are going to go for a multiprocessing to utilize all the CPUs, or you're going to go for a IO, multi-threading to just utilize all the threads, so that you can just reduce the latency and increase the throughput, right? So coming back to the here, so we can just quickly see, definitely there would be a 9 batches, the batch one summary, 25 This is what we have achieved rate, right? So you can see we have total 9 batches, so we can see all these things over here, right? So 16 threads, 9 batches. First batch is started at 25 files, the chunking and batching and all those kind of stuff will happen, and it will start doing that. So I have already explained, how you can just load this data in, few minutes. But if you don't do these kind of optimization, it is going to take forever, and it's just a 15 GB. But think about it, if you are going to have 100 GB, how are you going to do it, right? So it's a trading based application where it is going to be used. So that's the reason, first you have to think about different layers which we have in any given application. We have an application layer. I'm not going for that theoretical layers, but here, if you just talk about me, I will always look for the code first to just optimize as much as I can. And then I just go for the hardware level optimization, like whether I'm using, all the CPUs, all the memories which we have. And, and also I try to see what is the latest hardware which is in the market, if we can utilize that, and what kind of, performance improvement we can get by utilizing a latest hardware. And then we just go for the network. Like, if we are making any network calls, what kind of data we are just, trying to push through the network, whether we are compressing it properly or not. And there are a lot of other, parameter which comes into the picture when you are just trying to do the optimization at the network layer. So I would say you can just read through the network depending upon what kind of, logic you are writing. And then you can just change those network label parameter as well to increase the performance by reducing a latency and increasing a throughput, right? Same thing at the infrastructure level, as I mentioned, which is more or less covers the hardware aspect of it. But again, if you are just putting on a cloud, you have to make sure, what kind of resources you are spinning up, and based on what process you are running, and you have to establish, whether it's a CPU intensive or IO intensive, and accordingly you have to decide which resource to be used on a cloud. Otherwise your cloud cost is going to be increase very fast, right? So batch 3 is going to be run. So it is actually going to take, so there are some warning that I'll just help. And I know there are a lot of other improvement which I can still do over here, but this is how you can just, start improving, pushing our data, the large amount of data to the InfluxDB, right? So this is what, I just tried to summarize here. We have a data layer where we have a cleaning, right? So what I'm doing, I'm using a Joblib parallel so that I can just have a parallelization at the CPU level, right? And then we are using a CSV with pandas, again, chunk size and storage, and then InfluxDB tuning, which I have already talked about it. Then this data loading part, right? When we are going to do the data, again, the one more important thing, right? Because most of the time what I have heard is, people just start, creating a measurement inside the bucket without even thinking about what's their actual need is, right? So what they have to do is, they have to make sure, okay, let me just quickly check. InfluxDB is up and running. It seems like it is just, completely, so basically, this memory is completely utilized. That's the reason we are not going to log into that, right? But I have already explained to you in the beginning itself, and showed the data, how it's going to look like, right? So if I just log in, don't worry about it. It's going to take a little bit of time. Okay, so, and we know the reason why it is taking a little bit of time, because it's just utilizing, so it's okay, it's going to happen. Because if you just go to the resource monitor, you will find the reason, right? Because there's no space in terms of CPU utilization is also very high. So that's the reason we will see some intermittent. So that's the reason you have to make sure, you are optimizing your logic very cautiously. Otherwise you will messed up, your infrastructure, where you will not be able to log into the system, right? So it's still very slow, and which is quite obvious to happen, because we still need to optimize few more things, which I haven't done that, right? So now the fourth batch is running. Okay, so probably when the new batch will start, we can see the CPU utilization is still 39%. So this is still, there are a few things which are utilizing the CPU. So I really need to think about it, how we can do that, right? So still it's going to take time, right? So this is some few important aspect which you have to keep in mind. And one more thing, as I was mentioning, right, when you are going to create a measurement inside the bucket, you have to make sure you have to understand the concept of tag and of fields, right? In tag, you are going to only define those fields which are not going to change frequently. So try to keep those tags value as minimum as possible. Don't use any identity or the continuously changing values in the tag. Otherwise, your performance is going to be degraded very, very significantly. Put the tags only for those value. In my case, if it is going to be a trading platform, then I will be just putting exchanges, symbols, and whatever, I know that's going to have some finite value, some 10, 20 or 30 different values, because that is on basis of tags, InfluxDB is going to create the index, right? See, your system is again, not able to, allow you to get. So that is what, happens when you don't write a optimized code, right? So that's pretty much it. Sorry. So I was just explaining that tag, right? So I hope you got the sense of tag, like, and don't create so many tags, right? Keep as minimum as possible, right? And keep only those field defined as a tag which are having a finite values. And then a field, we know that this is going to take a temporal value. So it's depending upon what kind of precision you have, whether you have a nanosecond precision or the microsecond or the millisecond. And these fields are no, we don't have to worry about those part, because the InfluxDB is actually designed to store that data in a very optimal way. So this is InfluxDB 2, and since InfluxDB is 3 is already out there, right? So once I am done with this, so in this video I just cover the historical data aspect. I know I haven't covered in a very detail, but I have given you the very high level approach how you should do it. First, you have to look at the application label, then you have to go for the hardware label, then you have to go for the network label, memory, and all those kind of stuff. You have to profile everything. You have to look at the code. You have to just try to extract the time taken for each and every line of code by using a CPU label profiling, memory label profiling. And once you are done with that, and you feel that now CPU, your application code is completely optimized, your hardware is completely optimized, now then you move to the network layer, and you can see how you can just optimize the network label performance by reducing the latency and increasing the throughput, right? So that's pretty much it from my side. Batch 6 is running, right? Happy coding, and don't just try to write the code, try to write an optimized code, and just understand all those things, why it is important, right? The functionality is definitely important. First, you have to achieve the end-to-end functionality in the correct manner. Once that is done, then this optimizations come into the picture, and InfluxDB is very powerful. There are a lot of concepts, where people try to, create aggregation as well. So that aggregation is something which I will be covering in the next part, where we will be covering, how you can create, task, in the InfluxDB, which is going to run automatically depending upon what frequency you set, so that the aggregation can take place at the InfluxDB. But there are a lot of trade-offs, whether you have to create an aggregation on the InfluxDB side, or you can create a aggregation on the, application side. This completely depends upon your use case, like what kind of latency you want, whether you allow that aggregations of the data move to the InfluxDB server, or you want to keep it at the application level. That is completely experimental thing, where you have to figure it out what's the end-to-end expectation from your solution, and then accordingly you can decide whether you want to go for the application level aggregation, or you want to go for the Influx side, automatic task generation, so that the aggregation can take place automatically at the InfluxDB side. But again, you have to keep in mind, whatever processing you put either on the InfluxDB side or the application side, it is going to consume your resources. It is going to hamper, the processing speed on this either side. Like if it is on InfluxDB, it is going to definitely hamper that. So you have to keep in mind what you want to do, how you want to do it, right? And InfluxDB, again, at the hardware level, you can always go for a horizontal and the vertical scaling depending upon what you want to achieve, right? So it's not like you can blindly go about all these things. You have to learn a lot. You have to go through the documentation. You have to understand what InfluxDB is suggesting, and you have to do all those experiments, right? Since I have run this with the InfluxDB version 2, and definitely I'm going to run the same process with the InfluxDB 3 to see what kind of optimization we can just achieve by just simply migrating from V2 to the V3 side, right? That's one thing. The last thing which I wanted to cover, which I almost forgot, right? Some fine tuning. which you can do at the InfluxDB by the environmental variable, right? So these are the not which I am interested in, but I am interested in talking about this one, right? So where storage cache snapshot write, cold duration, right? So increase the in-memory cache before forcing a flush to the disk. So what happens, if you have heard that in InfluxDB use wall is write ahead log, right? So what write ahead log is? It's actually ensures the data integrity. So whenever you put any action to the DB, right, it uses in Postgres and I think almost in every database. There could be a different algorithm, but this is how it actually works in a very generic way, right? So whenever you put any request to the database, it actually gets into the well, and then it's actually gets executed at the data level, get the storage, and then if something goes wrong when you are trying to put that operation, so while is always having an entry because that's the entry gate for you, which actually ensures that whatever the request comes to the DB, it actually gets executed or not, right? So we can consume, we can just control this like up to what label, we want to keep that well, because if that well is going to keep increasing, your performance is going to decrease. So what happens in every database is once there is a wall memory which gets flooded, which gets exhausted, then it's try to just compact the data and just move it to the low cost memory, which in our case is going to be the disk, right? So this is where it says that how long you want to keep, what size you want to keep, and same how much duration, so you are just creating that, right? Cache snapshot, right? Cache max memory size. Similarly, I mean, you can just read through all these, different parameters. Very hard to remember everything, but you can just keep, compaction. Compaction is again whenever you just move your actual data to the low cost memory, right, on a disk, you always compact that, right, because that is where you want to have a compression, right? So concurrent write limit as well, right? So there are many more parameters which you can just go through the documentation, you can understand where to use what, and you can just try to do the experimentation by utilizing them and see, I mean, what kind of improvement you can bring. But definitely again you have to first understand the functional expectation, because fine tuning these parameter unnecessarily can increase the, because whatever the condition you are going to put top of the default, it's going to be respected by the InfluxDB. So make sure whatever the additional configuration you are putting, it's not going in the bad direction or the wrong direction. Rather than in that situation, what would happen if you just fine tune this parameter in a different way, then rather than getting the positive impact, you are going to get the negative impact. So just go through the documentation, try to understand all those parameters through which you can control the behavior of InfluxDB, and then you can be golden, right? So now coming back here, this process is done. Let's quickly just summarize that. So rate we just got is 210,000 points per second, which is very good. Total files are 215. Total points are 188 million, which I just talked about it. It's 1.42 GB per minute. So it took 17.5 minutes earlier. If you remember, it took 13 point something. So it's keep changing. It's just called the jitter of operating system or the hardware. I think jitter is the word which they use, where few things which are not in our control. So this can keep fluctuating, but if just keep fluctuating in the same manner, then we have to really think about it. Fail the fast data, so there are some failure as well, so no need to worry about that. Efficiency is good, but as I mentioned, there are still a lot of areas where the improvement can be done, right? So I'll just look at that and I'll see, I mean, where all we can just do some more optimization, right? Okay, so that's pretty much it from my side. And before I just wind up, let's quickly try to see whether we can log in now. But there should not be any issue because all the heavy lifting has been done. So we can see the data here. We can see the close. Now for ABB, right? We can just quickly customize that by time range. We can quickly see. So now we can see the data, right? For whatever the duration we want, we can quickly go for Adani. And we can see it, right? So now the data is loaded. As I mentioned, now the InfluxDB is pretty much instantaneously responding us, right? Earlier, it was not even allowing us to get to the, and we can quickly see 2 days, right? So there are data points, right? So we can see that. So data is loaded properly. Okay, cool. So now the one thing is what I wanted to show you here. If you just see the measurement and fields, right? So in ticker, right? This is my tag, right? Apart from ticker, I haven't used anything, but the additional one which I can use is exchange, right? But don't go for additional tags until unless there is a need for that. Why? On what basis you will find a need? whether you want to filter our data on those fields. So ticker is definitely you want to do it. Exchange, again, it could be another thing where you will do it because you will have a same symbols on different exchanges, right? Or you want to segregate the data, right? So exchange can be the another one. But in fields, you can see we have a 5 fields: close, high, low, open, and volume. But here, so you have to keep tags as minimum as possible depending upon your use case. But your fields can be definitely, it completely depends upon your business case, how many fields values you want. So I think that's pretty much it from my side. I mean, how you can do the optimization on InfluxDB, how you can load the large amount of data, right? In the next video, what I'm going to do, I'm going to create one mock server where we can consume the data in a real time. And we will try to reduce the latency as much as possible. So I will just give you some more tips how you can, optimize your code to just ingest the real-time data into the InfluxDB. So that's it from my side for this particular video. If you have any feedback or suggestion, if you need any kind of optimization tips from me, you can always put that into the comment section and I would try my best to help you on that. You can always drop me an email as well by just describing your use case where you just got stuck and what kind of help you need from my side on InfluxDB. I would love to help you on that. So on this note, thanks for watching this, and if you haven't subscribed for my channel, please subscribe for my channel. And stay healthy, keep learning new things, and be curious as much as possible.